Let's talk about polynomial functions. Here's our definition. Some important things to note: that the exponents on the x all are positive integers. And the leading term of a polynomial is the term with the biggest exponent. The leading coefficient is the coefficient of the leading term. When we talk about the degree of a polynomial, here's some examples of a polynomial, of different polynomials. The degree is the biggest exponent. So even if it's out of order, like this one, it's not necessarily the first one, it's the biggest one. This is degree 4. Polynomial graphs kind of look like roller coasters. They go up and down, some are more interesting than others, but there are no holes or breaks in a polynomial, and they go forever to the left and forever to the right. Important points to note on a polynomial include the x-intercepts, which we could also call the roots or the zeros. Another set of important points are the places where the graph switches from either increasing to decreasing or switches from decreasing to increasing. We've called those points relative extrema, we've called them relative mins, relative maxes, we could call them turning points. Another important thing that we want to be able to do with a polynomial, and I'll point out that the dark green polynomial actually does continue on down there. It just got cut off with the cut and paste. Both of these are polynomials. This bottom one is also a power function. These both have the same leading term, and if we remember our rules about end behavior with power functions, then we can predict the end behavior of a polynomial that has the same leading term. So an even exponent, a positive coefficient, means that the end behavior is going higher and higher and higher, going to the left and the right. On this power function, also this polynomial. Here's another example. These are both polynomials. They have the same leading term. This power function has an even exponent, a negative coefficient. Since it's negative, that means going to the left and to the right, it gets more and more negative. Same in behavior for this polynomial. Here's an example with an odd exponent. Same in behavior. The polynomial just is a little more interesting in the middle. Here's a final example.